Okay, let's look at this question here, which is on PnC. So this was asked by one of my AC students. So find the number of 4-letter code words that can be formed from the word address. Okay, and the first thing is to list down what are the identical letters. So what are the distinct letters you have? Okay, so always count, write it down, and then tally them. I think usually that's what I say. So you have 1A, then you have 2 Ds, right? Okay, then you have 1 R, then you have 1 E, we have 2 S's. Okay, so once done, you just count like 2, 4, 6, 7. You have 7 letters here. Okay, 7 letters, and you have got how many distinct choices here? 1, 2, 3, 4, 5. 5 distinct letters. Okay, you can't choose the identical letters. Okay, in PnC, you can't choose, all right? So just check. You have 2, 4, 6, 7. 2, 4, 6, yeah, 7. So you have 7 letters here. So you always tally before you start. Okay, so now then after which you need to ask yourself what are the different cases you can have, because the idea is by choosing different letters, the number of identical letters would involved in the 4-letter code word will have different arrangement, right? So you need to go down each cases and think which case is viable. So for example, case 1, you can have 4 distinct letters. So usually what I tell my students to write is, to be quick, you can just write V, W, X, Y. Okay, just some way for you to demarcate it or to understand. These are 4 distinct letters. Now obviously the other way, case number 2, we can have say V, V, X, Y. Okay, then case number 3, we have V, V, X, X. Okay, meaning to say we have 2 pairs of identical letters. So for case 2, we have just a pair of identical letters. So case 3, we have 2 pairs of identical letters. Then after which we have got, we could also case 4, V, 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 X, which this will not happen, because what happens is the limiting factor here is that the identical letter here, we only have like at most 2, right? So this will not happen. So some other words may have case 4, okay? Case 5 as well. Case 5, you can have everything, right? Or like all of them, like just one identical letter here. So like that, right? So just check if you have any like cases missing here. So if no, we can just start counting, right? So this case here. So for the first one, if you want 4 distinct letter here, just understand that you have got like 5 distinct choices, right? You can't choose the identical letter. So for example, if I give you 2 red balls, right? Red identical balls, I ask you to pick one, you do not have the choice, because whichever ball you pick is actually the same ball, right? So you cannot choose identical objects, okay? But in probability, we could, because we are using a principle called a bijection principle. But in this case here, we don't, right? We can't. So here, what we have is a 5 choose 4. Okay, you have 5 distinct letters here. Then you pick 4. You pick 4 to just choose them. Then after which you multiply by 4 factorial. Okay, 4 factorial because the number of ways you can arrange 4 identical objects is 4 factorial. Or you can write this as 5p4 as well, not an issue. Okay, so the first case is 5p4. Now then after which the second case, what we have is, you must understand that not all letters could be qualified as VV. In these letters that we put here, we only have got 2 letters here which 2 distinct letters here which qualified for VV, which is actually D and S. Okay, so when we say VV, it's actually 2 choose 1. You're choosing from these 2 types, you're choosing that one letter to fit into this VV here. Okay, in some, you think about it, there are only 2 ways for you to have this identical letter, which is DD or SS, right? So these are 2 options. So it's 2 choose 1. Okay, so oftentimes students make a mistake by writing 2 choose 2, because they think that you need to choose the VV individually, but it's not. You need to see this as a group. Okay, once done, this is XY, right? XY will mean that once you pick one of it to be VV, you leave you are left with 1, 2, 3, 4 distinct letters to choose from. So that will be 4 choose 2. 4 choose 2 here, right? So this will be 2 choose 1 multiplied by 4 choose 2. Then after which, what you need to do is multiply by 4 factorial over 2 factorial. Okay, so in this case here, so I don't really like to. Sometimes I'm just going to erase the 5p4 because I'll just write in PnC. So choose and permutate. Okay, so this case is done. Then the last one is the trickiest. Okay, we know that case 4 and 5 will not happen, right? Case 4 and 5 will not happen, so we don't have to worry about it. Case 3 is the trickiest because this is two groups here. Only these two types. Okay, VVXX, there are two types. So there are only two letters which qualify for VVXX, which is D, E, and S. Okay, so it's 2 choose 2. This is the one that usually students get confused. In fact, you only have one outcome to choose VVXX because it's DDESS. No matter how you choose, DD is always DDSS. So 2 choose 2 is only one outcome. This is the only outcome you can have for VVXX. Okay, once done, the way you choose it is 2 choose 2. Then after which, when you arrange it, it will be 4 factorial over 2 factorial, 2 factorial. Okay, so you sum them up, you should be able to get the answer here. So this case here, you have 270. Okay, add them up. Okay, so that's how I do this question proficiently. If you have any questions, please do let us know, and I'll see you in the next question.